Academic language and literacy within the science discipline is deeply embedded in the next generation science standards. When we look at the wording of various standards, we see terms like plan and conduct, develop models, communicate scientific and technical information, analyze data to support claims, or supporting claims with evidence. Additionally to the science standards, we see that ELA or literacy standards are also tied in to the science discipline with your writing and your reading standards. Citing specific evidence, again, comes up, right? Drawing evidence from texts, writing explanatory or analytical text that's focused within the discipline and uses strategies to convey information like those used in respective disciplines. So this standard in particular, but all of the next generation standards and the ELA and literacy standards that are connected to them are really geared toward getting students to a place where they can authentically communicate, read, write, think within the discipline that we are teaching. So for example, in science, having students begin to read, think, and write as a geologist, a seismologist, a biologist, a doctor, oil and fish and wildlife conservationists, right? All of these different roles, these standards are trying to get those students thinking, reading, writing in those specific disciplines. Even when we come down to more standards, we see things like refine the design of a chemical system. That's going to include a lot of writing and reading and thinking in that process of refining a design, right? Developing models, constructing and revising explanations. That's all part of the reading, rewriting, and writing processes that we ask students to do in our classrooms. And these standards are really trying to get students to a place where they can do that. Now, as teachers, our role is to support our students in getting to these standards and meeting them. So ways that we can do that are having lots of visual supports around the room, maybe a question wall where we write down questions that classes have so we can have more inquiry-based learning, right? Having anchor questions or essential questions up on the board so we know in the direction that we're going, right? Having visual supports. If we've covered how a paper is written or an article or a letter or a different genre within the discipline is written, maybe having that support up on the wall so that when students have the autonomy to choose an assignment, they have the support they need in order to do it. They don't have to go looking or question how to form something. Providing the supports and scaffolds throughout lessons is really important. And modeling, just like Ms. Metzi said in that prior slide, modeling for students or explicitly showing them how scientists work with language and through the reading, thinking, and writing process within the discipline is essential. If students don't see how writing, reading, or thinking occur within the discipline, often they cannot make the connection they need in order to replicate that on their own. So some strategies when it comes to modeling or providing supports within the classroom that I might use might be breaking down different genres. So some genres like letters or comics, they have a very similar form regardless of the content area that you are having them being written in. A letter in ELA class will look in its form the same as a letter in science. The content will change, but the structure remains very much the same. And so if we, or if I, were to work with my fellow teachers, we can make sure that all the genres that students would see in their daily lives or in their future careers is hit in their explicit teaching. But things like scientific articles or scientific journals, those are much more specific to the discipline. And so those need explicitly modeled and taught to students in order for them to be able to receive the information off the page. So if we're looking at an article, we have to explicitly teach students how to read a scientific article. That means dissecting the text, finding out what the bold letters mean or what bold words mean in a text, like a scientific article, right? What the conclusion might look like in that article, where references might be and how they're formed. All of these terms need explicitly modeled and taught before students can be expected to authentically write in that form in the scientific discipline. And so breaking down text through modeling is one way we can support our students. Another way is supporting them throughout the reading, thinking, and writing process. And so what I have, or what I'm going to show you, are just some of the ways that I might, as a scientific teacher, provide those supports to my students in my own classroom. Before reading occurs, I really firmly believe that prior knowledge needs to be engaged. And so a picture walk, or often within the discipline you'll hear phenomena, must be shown. It could be a video that's on a loop that's just showing a specific phenomena that has no words or audio involved. You're asking students to look, observe, and just make some inquiry questions. That in itself can be very hard for students and might need further broken down and structured for them to start that process of thinking about what they're seeing and questioning. The standards, the New York State Next Generation science standards, are very much phenomena-based. And so that prior task before reading or writing occur, where you are simply generating questions or hypotheses, is really important when hitting those standards and when preparing students to really start thinking about how to problem solve and start that process of thinking within the discipline. Reciprocal teaching is also something that I might choose to utilize when breaking down a text with students. It's again asking students to make a prediction about what they're going to be reading, questioning as they start reading, so it's still extending that thinking process, clarifying what they're reading, and summarizing, and that would be toward the end of the task. But this allows students to really take ownership of the text and how that might look as a scientist thinking while reading the text. One support that I might provide students while reading is occurring is an anticipation guide. Now, this guide can be used before, during, and after the reading task. Again, you have the statements, much like the prediction in the prior example, or the statements of the text, and then what the reader thinks, much like the prediction, what the text actually says, and the evidence from the text. So this is hitting a lot of those standards because it's asking students to go back in the text, retrieve evidence that supports what the student thinks or what they got wrong. So you're, again, training students to go back and reread text in order to gain evidence to support their claim. And that's a lot of what science is, and a lot of what the standards are asking students to be able to do. After the text is done, I might use a Frere model in order to really get students thinking about the discipline-specific vocabulary and making those connections in the students' learning process to what the vocabulary means within the discipline. This Frere model could be used before reading as a predictive strategy, or after reading as a clarification of a term or discipline-specific vocabulary. Vocabulary will go in the middle, characteristics, definition in the student's own words, and that's key because that's asking students to identify what the scientific definition is, and it's asking students to engage their prior knowledge and put it in their own words, summarizing what they've done. Examples and non-examples. I've also seen this for sections done in visual, so asking students to pair their writing with a drawing so that it is using more than one multimodal approach and solidifying that information in their brain. So that would be the reading process. Again, reading is never a one-time deal, especially in science. You're constantly going back and pulling out data to support your evidence or going back to revise your own thinking. When it comes to moving from reading to writing, I think sometimes what doesn't get supported as much is how students can pull their thinking out and put it onto paper. And that in itself can be very daunting to students. So I firmly believe that supporting students in that task is important. And one of the ways I might do that is a sticky note strategy, where it's not as focused on grammar or the specific vocabulary dense writing that I'm looking for students to do, but it's just about getting their thoughts onto paper and then organizing those thoughts in some way. So, for example, and this is talking about argument, but it could be for any type or purpose of writing. For example, if I were to go with this strategy, I might have students make a hypothesis or a statement. I would adapt this document. And then find evidence in the text, write it down on a sticky note, and place it in these different things. And then on another sticky note, start thinking about how that evidence is supporting their prior statement, right? Finding opposing evidence and how it's not as important as the others in order to support them in writing a persuasive, argumentative piece. This can also be adapted, of course, for an informational piece. All it's doing is it's a lower stakes form of writing when it comes to getting students to start putting their thoughts on paper. And so that might be how I support students in that transition from their reading to their writing process. Raft is something that I feel really strongly about within a science classroom because it's asking students to take on a different role. So it could be a geologist, a seismologist, a biologist, and write in a way that's asking them to consider their audience. And that will affect their format, and their topic will affect how they write as well. I went ahead, and you'll see in a slide within this presentation, I've added one letter, and that would be P for purpose. I do feel like it's very important for students to consider the purpose of their writing, even as a geologist, a biologist, any of the different roles. If I consider all the other parts, the audience, the format, the topic, my purpose still might be different. For example, if I was a soil and water conservationist and I was writing to the local city, right? And I'm writing to inform them about concerns I have with the lead content in the soil, right? My purpose would be informational. I could also, as a scientist, write to and so that would affect my format. As a scientist, I could also write to the city and talk to them about the same topic, right? The lead content in the soil, but my writing might be more persuasive. Still using data, but my language would change. And so I think that that's an important piece to bring in when students approach writing authentically within the discipline. Paragraph shrinking. So this is asking students after they've completed their first draft of writing to go back in and revisit the text, because that's something that we as teachers and as scientists need to explicitly show our students is part of that process, of the revision process, of the writing process. So those are some of the different strategies I might use with my classroom when it comes to supporting them in reaching those next generation science standards, in developing a model, or planning and conducting an investigation, or even when hitting the ELA or literacy standards, writing an informative or explaining text focused on discipline-specific content, right? That is exactly what these strategies would be designed to do, and these standards are exactly what a student who goes into this discipline will need to do authentically in order to communicate in the discipline of whatever science they choose. And so I think that as teachers, again, it's important to provide visual and auditory and written supports within our classrooms so students can authentically write within the discipline.